Errors. A type 1 error is when you reject the null hypothesis when the null hypothesis is true. A type 2 error occurs when you accept the null hypothesis when the null hypothesis is false. We can represent these errors graphically. Imagine the red distribution below represents the distribution for the null hypothesis, and the yellow distribution represents the actual distribution of the population from which the sample is derived. The green line represents the critical value of z for the null hypothesis distribution. The area under the red curve to the left of the green line is the area in which there exists potential for type 1 error. If the z-score pulled from a red distribution sample is one of the small proportion that has a value in this area, then the null hypothesis will be rejected, even if it's true. The area to the left of the green line under the yellow curve is the area in which there exists potential for type 2 error. In this area, values that are part of the yellow distribution will not lead to a rejection of the hypothesis that the red or null distribution is the correct distribution. It is important to remember the meaning of type 1 and 2 error, and to be aware that hypothesis tests do not definitively prove hypotheses. They simply support them. Choosing an appropriate level of confidence will help you to minimize the amount of error that's likely, then that's appropriate for your test. Welcome to this elementary statistics tutorial in which we'll take an in-depth look at hypothesis testing. In this lesson, you'll learn the graphical interpretation of hypothesis testing, the difference between one- and two-tailed tests, and how errors in hypothesis testing occur. Recall that a test statistic for a z or a t-test is a measurement of the distance of a certain value from the mean of a distribution in standard deviation terms. Look at the formula for the z statistic, for example. Z is equal to x, the value, minus mu, the mean of the distribution, divided by sigma, the standard deviation of the distribution. So it's the difference between x and mu normalized to standard deviation terms. So if a z-score is equal to 1, x minus mu is equal to the standard deviation, or x is equal to mu